Hi, my name's Tom Marks. Welcome to another PlayStation 2 programming livestream. Today we're going to do some exciting stuff. We're going to work on asset loading. We're going to do some hardware verification because I've got a capture card set up. And I think the very first thing we're going to do, I don't want to mess around too long. Let's jump over and have a look at my PlayStation 2. This is it. Let's make myself a little bigger. I haven't used this scene yet. This is brand new scene, brand new concept. Where do I belong? Here, maybe. Zymus, good morning. X-Links, good morning. Let's run my game on the PlayStation 2. If you haven't seen this game before, prepare to be underwhelmed. But it's still exciting, right? Running something on the actual console. Side scroller test, make, see, source, run PS2. Here we go. Okay, so this is a program called PS2 Client. It lets me load code over the network. This frame buffer, little ghost, is from my game. For some reason, when I run a game, I don't clear the frame buffer properly, so while it loads, it shows a black screen that actually has part of a frame buffer in it. I don't know, I need to fix that. Whatever you were running last. And also, for some reason, like I'm not pressing any buttons right now. Okay, maybe I need to reset the console, because there's this weird thing about my controller handling. Maybe I can replug the controller. Anyway, this is my game. You're a little guy, you can move around, you can jump on things. I can't move to the left because of a controller bug, that's okay. And then it just crashes, so that's cool. I don't know what that is. This error says bad vAdder, so I guess it's probably a VRAM address thing. Xlink says happy Halloween. We don't really do Halloween here in Australia. Also, it's the 1st of November here, but thank you. Happy Halloween to all my American people. We kind of do Halloween here now. It's in a weird place. I should be able to reset the console without actually pressing the button here, or reset the program, so that's cool. Halloween's in a weird place. People like to do the parties. Bad virtual address, it's a seg fault. I don't know why it's a seg fault. Thank you, Zymus. I don't have chat. I don't have bring up chat on this scene. I should probably do that. Also, I'm going to replug my controller and see if it fixes this ghost input. Okay, I'm still moving to the right and the controller's unplugged, so that's weird, right? I'm gonna reset the console. This is what happens when you try and hardware verify stuff, right? Oh, these are the kind of quirks you only get when you're working with hardware, and I love it. So this is a problem with my controller reading code that I need to resolve. So if you haven't seen FreeMcBoot before, that's a system, a hacked memory card that lets me run different programs through a hacked ODSys menu, which is great. Let me try that again, because this doesn't always crash. It only crashes sometimes, and it never crashes in PCSX2, so I don't know what I've done. And you can see this time the bugged frame buffer is the ODSys background, the little spinny orbs. So now my controller is behaving. If I get that virtual memory, if I get that crash, that exception handler, while I'm pressing a button on the controller, that button never gets unset. So the next time I run the program, it'll still be held down. Also, you can kind of see just at like the very bottom of the frame, like here, hold on, not here, here. It's gone now. There was like a bit of ghosting. Was I pointing the wrong way that whole time? Anyway. So this is my game. This is it running. You can actually jump on stuff now. You have a bit more control over your guy. And I have this system where this shitty looking area with weird test tiles is one level chunk. This place with a real tile set is another chunk. And then when I hit the halfway point about here, which is where I've been crashing. I don't know why I'm crashing. That's weird. Let me see if that happens on the emulator as well. Maybe I did break something off camera. That's annoying. What should happen there is we load another level, another chunk of the same level. Workspace, PlayStation 2, side scroller test, make, see. Okay, let's test this in an emulator. I don't have a controller plugged in. I'm running out of USB ports. Not that one. Now that I've got a capture card here, I have too many things plugged in. It's a little bit hectic on my desk. I also have a keyboard that was plugged in, but now isn't. Okay, cool. So this looks a lot nicer not going through a composite cable. Yes, now I do know this. Zymus says, also, hello chat, welcome to being on stream. I need a better solution for this, but that's okay. You can use adder to line to get the source location corresponding to the crashing program counter. I really, yeah, that's a good point. Unfortunately, it's very hard to read the number on stream. I don't know if you guys are able to read it. Anyway, let's see if it works here, or if I'm gonna crash as well. No, it works fine there, so that's weird. I wonder if the crash, because it loads from a host file system, I wonder if the crash is to do with that more so than my actual code. Like maybe the crash is not somewhere that I control. That is possible. It's also possible that it's just me. Super Cricket, I hate it when my code works too. I hate it when my code works when it shouldn't. I hate it when it selectively crashes, right? Only crashes in one environment. It's the worst kind of thing. Either way, I think it might be worth trying the same kind of thing, which is instead of loading different files, because we obviously load files successfully at one point, and the less opening and closing of files you have to do over the network, the better. What I was observing when I was running this, could be some data alignment issue. That's interesting. That's a good point. What I was finding is it just took a really long time to load a very small file over the network, right? How big is my file? Source, it's tiles test O, right? This is that didn't actually tell me how big it was. It's a 33 kilobyte file, right? Sending that over the network should be pretty much instant. And for some reason it was taking like multiple seconds to actually load that. And I imagine it's a hostfs implementation thing for PS2 client. I don't know how it's really supposed to work. So anyway, my theory is that, and let me plug my mouse back in. My theory is that it'll be more effective to pack my files together into a WAD, right? So what's a WAD? A WAD's a file that just contains a lot of other files. So currently we have, file 1, file 2, and file 3, right? Let's call them F1, let's call them F0, where we zero index here, F2, F3, and when we want to read a file, we've kind of got to like open the file, read the contents, and then close the file. What I propose is something, a trick that many games do. I'm going to take most direct inspiration from the work I did unpacking files from Kingdom Hearts. Have one big file, like a really big file, called like a WAD or something. If you're in Doomland, a WAD is probably the right kind of thing. And this file it is just a big concatenation of other files. So inside this you have, some block that belongs to F1 or F0, and then F1, and then F2, right? They're all just in this one big file. But then you also need another part of this file which tells you, if I want to get file 0, what address do I get that from, right? How do I go from a name to that? And basically, the way I've seen it done in lots of games is to have your index be a big list of tuples where you have a hash, an offset, and a size, and then maybe some extra field. And this is it. This is your index. So when you look up a file, say you look up F0, you hash the name, you find the corresponding entry with the same hash, you get the offset, and you read it by its size into some buffer, and you're done. That's file IO. I think this is going to be better because we can just have one file open the whole time. This also works better with disks, right? Disks spin, I don't know, there's some property of disks. It's easier to manage stuff if you do it like this, rather than having a bunch of files on an ISO 966 whatever file system. Navigating a whole file system sucks. So just doing this lookup from in-memory is better for some reason. This is what real games do, right? This is what Kingdom Hearts does. This is what a lot of PlayStation 2 games do. And also, I'm pretty sure this is basically what Doom does as well, right? Doom 94 WAD. Let's have a look. Let's see if there's a specification for the WAD file. Here we go. WAD, where's all the data? That's right. Doom, 2-based engines, header, lumps that make up the resources. Yeah, cool. A header, ASCII characters, number of lumps, pointer to the directory, pointer to the start, size of the lump in bytes, ASCII string defining the lump's name, which is, so rather than using a hash, this uses an 8-character name, which It's kind of silly. Anyway, why not just hash the name? But yeah, so that's kind of cool. That's kind of cool, right? Just a way of lumping a bunch of data together so you don't have to have a bunch of small files. You can put them all in one place. And there are reasons. And I really think that, especially doing this over the network for testing, this is going to be more performant. But the only way to know is to build it and find out. So let's try and do it. Let's try and do it. Okay, so what... Are we in a branch? We're in main. Let's check out a new branch. Git status. We're fine. Let's check out a new branch. And let's call our branch WAD. Our WAD doesn't stand for where's all the data. It's a WAD. It's like a big meaty WAD of data, right? It's a different name derivation. So let's go source wad.c. Or maybe I should call it io.c or something. I'm going to call it wad.c. And if this is performant and this works well, I'm going to promote it to the main library. But for now, we're going to implement it just in this game. So let's start with the obvious thing, which is struct wad index. Am I going to call it a wad index t? No, I'm just going to call it a wad index. We're going to have a uint32t. This is going to be a hash. We're going to have a uint32t that's going to be our offset within the wad. We'll have a uint32t, which is our size within the wad. And then we'll have a uint32t, which is our extension, which is going to be unused, but it's going to be there in case we need some flags or something for later use. Excellent, excellent. Then we need the actual wad itself. Struct wad file. This has a struct wad index. It has a struct. No, it doesn't have a struct. It has a size t. So this is, you know, like our list, our entire list of indexes. We have a size t, which is index length. Or index size, maybe. I can never remember which name is better to use in C style, but we'll go with size for now. We'll do size. Size is good. Size is good. Cool. Index size, and then we need the actual data. Void data. Beautiful. So this struct definition should come first, so we don't have to forward declare anything. We need to put semicolons at the end of struct definitions because C, which is fun. Let's go. So how do we read something from a WAD, right? How do we do that? What does that look like? Let's have a function. Let's make it return an int because I like functions that return things. What's our kind of structure here? Let's say WAD read WAD. Oh, Doom checks the 8-byte name by doing 2 U32 compares. That's actually really cool. That's a good bit of trivia, and that makes so much sense. Like, 8 characters, 8 bytes. I mean, on the PlayStation 2, we could probably do 16. We could probably do 32 bytes, right? And just turn them into 128-bit compares. Or I guess do 16 bytes and just do like one 128-bit compare. I guess the E core has an instruction for that, right? That's a fun idea. That's a fun idea. But we're gonna do a hash. I like hashes. I don't see why you wouldn't hash because it means you can just have long names, and long names are good. I don't want to have to shoehorn everything into awkward awkward character limits. So wad read file. Okay. Let's say the file. Actually, no, let's not pass in a char for the file name. Let's pass in a uint32t. So we'll pre-hash it before we call this function. We also need this pointer. We need our struct wad file. This will be w for wad. Because in C, you know, you don't have like a class with an implicit this pointer. You just have to make it explicitly the first argument to every function that kind of operates on a thing. And that's fun. I like that. I like being explicit. File name hash, and then we need a buffer that we read out to, target buffer, and size t target buffer size. Except this is too much stuff for one line. My linter would yell at me for that. Okay, beautiful. WOD read file. Despite the fact I don't have a linter set up for this repo, I've got to change it because my linter would would yell at me for that. Cool. So the idea is, and we're going to do this the stupid way, right? If we were smart, we'd make the index, we'd make this like a hash map or something, but when we're just going to iterate over it linearly. Because opening files, like, it's good if it's fast. Actually, the other thing we could do is sort them. We could make this sorted and then do a binary search. But for now, we're just going to do it linearly because we're dumb. We're big dummies. Your parser error could be, that's a lot of long words. Too bad I ain't reading them. That would be fun. I should add that to my programming language, right? If you have a line of 80 characters, it's like, nah, I'm not doing that. I give up. I quit. My programming language will have some kind of effective like program size. So maybe that should be my error message. That's a good. I'll save that somewhere. So let's do something funny, and let's see if we can write a function that returns this struct by value. Index entry, right? So we'll pass in our WOD index size and our file name hash. I guess the problem with getting something by value is we have no error case. So I guess let's just make it a pointer, and then we say if not index error, something error. Let's log an error, let's say file not found. And then we return 0 for error. I need to be consistent with this. I'm a little bit inconsistent with it at the moment, but that's okay. We should probably also do this for if not w, log error, null wod cool. Okay, so oh yeah, hold on. This, I don't want to have the whole WOD in memory, do I? I want a file that I can like read from. I want to do it like this. You know, a WOD in theory could be really big, right? If you have a game like Kingdom Hearts, all the data adds up to like 4 gigabytes almost. You can't put the whole WOD in memory. You can't put the whole data file in memory. And now, in the case of Kingdom Hearts, it's actually written directly to a disk, right? We're talking about like reading blocks from a disk. But in that case, we're not really going to mind that much. We're not going to be that fussed. We probably should, in theory, and maybe it's better to define this now, const block size. I guess it's going to be a const size t, maybe, block size. And this is like the smallest thing we can read. If we have an actual disk, the disk has blocks. They're like the units that get written to the disk. And we don't want to start reading halfway through a block because I said so. I don't completely understand the mechanics of reading and writing from a disk, but so I don't really know, like, I think this number can change depending on how you write the disk. I want my games to eventually be able to run from a disk. That's something in the back of my mind to do one day. So it's probably good to define things with some kind of block size early. Anyway, so let's assume we get an index entry, and this doesn't have to be a public function. This can kind of be private to my WOD code, because the only way anything should really interact with this is by calling read file, right? Or write file or something. But again, it's a PlayStation 2, so we're not really going to be writing data. This is like a read-only thing. Only read, no write, only read. Cool. So we have an index entry, and then all we do is we say fread, I think. Oops. Fread. Yeah, fread. Standard C library functions to read or write from a file. Fread. Nmember items of data, each size bytes long from the stream pointed by stream. Storing them at the location given by pointer. So pointer, size, nmemb, stream. So pointer is the pointer is target buffer the size, let's say, now, which size do we care about? We want to read the actual file size, so we need to do a check first. We need to say if index size is greater than target buffer size. This is an error. We get very, very upset here. We need to log an error and say, read file target too small. And let's put the hash of the file in here as well. Hopefully the next layer up, when we detect there's an error, we can log the name of the actual file. But, you know, here we'll just log the hash because that's all we have. File, name, hash, target too small. We want to maybe say index, size, target, buffer, size. Return 0. Awesome. Target buffer. Okay. Target buffer. Size is going to be index, size, number of members is 1. We read one thing of that size, or size things of size 1. I don't know. I don't know which order these arguments are better to go around in. I don't think it really matters. And then wad f, the file, the stream. Cool. Now this should return the number of bytes read or written. Awesome. So if fread not equals index size, then something went wrong. Warn, maybe? What's it called? Trace, info, error, debug. We don't have a warning level. In theory, we have a warning level. In practice, we don't have a warning level. Let's make it a log error. Failed to read enough bytes. File name hash. And I guess we should return 0 here as well, because that's not good, right? If we don't read enough stuff, that's a bit of a problem. Otherwise, we just say, yep, we're happy, everything's good, we've read stuff into our target buffer from our index, you know, our file represents some stream. Thmo, how am I? I'm doing good, I'm doing great. I got my hair cut, you know, I'm job hunting, I'm feeling good about life, It's fantastic. How have you been? I don't think I've seen you in my chat for a little while, so I hope life is going well, I hope life is treating you well. Here's the other thing that I forgot to do, hold on. I just said read, but I need to seek as well. I forgot to seek. I need to do a seek. Oh, is there a lower level read? There is, right? FD count, yeah. Maybe the lower level read's better. I don't know. Let's go F seek. We need to seek to the right spot first, right? Because if we just read, where are we reading from? I don't know. You know, we could be doing lots of reads. So we need to do an F seek. And we need to say, the first thing we need to do is F seek the file from this wad. We're gonna seek to index block offset times block size. So we can only seek to offsets, to multiples of 1024. And maybe this should be configured as part of the WAD file, I don't know. Size t block size. And maybe it's hard-coded, but making it more, the more flexible this is, the better probably. Times WAD block size, and whence we say seek set, because that's the start of the thing. Nice, okay. I've been doing good, a lot of work. What do you do for work if you're happy sharing? If you're not happy sharing, don't share. But if you want to talk about what you do for work, I'd love to hear, assuming it's programming and stuff. I don't know. Maybe you scrape barnacles off of boats. I don't know. But yeah. Software developer for IBM. Damn, that sounds prestigious. But also, IBM, I don't know if they're good anymore. When I grew up, IBM were kind of cool. These days, they don't get a lot of respect. Bobbius, good morning, how are you going? Or good evening, I should say. Happy Halloween, I should say, because it's still last month over in America for a few more hours, I think. Nice. Yeah, how long have you been at IBM? Like, what do you do? My experience with IBM is largely because I worked at a bank, and our like core servers were IBM mainframes from the 1980s. They did all the maths, they did all the transaction stuff, and then we had layers and layers of abstraction built on top of them. It was like an onion. It was kind of incredible that it all worked at all. fseek. What does fseek return? Rewind. Successful, they return 0. So I guess the other thing is, if not fseek, then something's gone wrong. We want to say log error failed to seek. Let's do this. D, I guess, file name hash, and then index block offset. Cool. Return 0. We're not going to read the right data, so there's no point even trying. Your girlfriend says my new hair looks nice. Excellent. I love it. I'm getting so many compliments. I'm going to get a really big head, but that's fine. It's been good. It's been good. Yeah, I'm feeling very crisp. I was really worried that having shorter hair was going to make me look older, but it makes me look so much younger, and it also means I can grow my beard out a bit more without looking completely feral, which is great. You work for consulting, so with a single client. You like IBM, they have good benefits. A bit bureaucratic, but it's nice. Yeah, those big companies, there's always, especially the older they are, and IBM's pretty old, right? Yeah, like great benefits. They can look after people. When I worked in the bank, you know, I didn't like the bureaucracy, but they really looked after me, which was cool. I look nerdy. I think the turtleneck isn't helping, right? It's a bit of a Steve Jobsy vibe, maybe, and I don't know how I feel about that. But my neck was cold, so what are you gonna do? What are you gonna do? Okay, so we need to import some stuff, right? We need to include stdint because we're using uint32t. We need to include stdio.h, maybe. Where does this live? What header? stdio, cool. And fread, not low level read. I want fread. Freed. Freed is also stdio.h. Cool. Those are all the headers we need. Okay, so we can, in theory, read a file from WAD, which is great. What if we want to make a new WAD file? Let's say WAD open. Okay, we'll have a file name. So we'll have a const char file name, right? The file we're actually opening. You work for a bank too. IBM's very old. IBM's like shockingly old. I can't remember how old it is. They're like over 100 years old, right? Like it's actually kind of crazy. Like was IBM like wasn't their original name or something? They renamed. I can't remember. I'm not going to Google it because otherwise I'll fall down a Wikipedia hole. But it's something like that, I think. Cool. So file name. What else do we need to give it? Maybe a block size. Maybe that should be part of the WAD. Like maybe our WAD needs some kind of WAD header that we can read, and this will tell us. We'll have uint32t. Maybe some kind of like version, some kind of identifier that tells us that we've got the right thing. We'll have index start, index block offset. Which block offset the index starts at? Maybe, or maybe not. Does the index just come right after? We just like in this first block, basically, right? We assume we have the index. That's a good point. That's a good point. We'll definitely go index size, or index entries. Cool. Yeah, let's do that. Let's do that. Cool. port this code to ESP32. We're writing code for the PlayStation 2. There's a bit of a difference. There's a pretty big difference. But this would be very applicable, and other people have implemented things like this much smarter. Computing, tabulating, recording company. It's a bit of a mouthful. I see why they chose IBM. What am I coding? So I'm building a game on the PlayStation 2. It looks... I won't show it again right now because I've got this weird crash, and it's going to be easier to debug that crash potentially once I'm doing file I/O like this. But because my file I/O kind of sucks, and because I'm testing things over the network, I use this cool program that lets me run games and binaries and stuff over the network. Like I've got an Ethernet cable plugged into my PlayStation 2 into my router. And I run them via the PC using a program called PS2 Link or PS2 Client. But opening new files seems to be slow over that network, so I want to try putting all my files together into a WAD. This is also how real commercial PlayStation 2 games do file I/O on the disk. Because spinning disks are complicated. You kind of need something a little bit more than just using an ISO file system. You're going to hit some limitations there. Cool, so if we open a WAD, we have a file name, and I guess... maybe we also have a struct WAD file, because we don't want to allocate, right? We're going to write out to some target. Cool. So if, let's open it. Let's say open, maybe. Have I used some weird, it's just fopen. It's just fopen. Okay, so let's say file, f is fopen, file name, RB. We're reading the file in binary mode. You're going to follow me on GitHub. Please do. Please do. You can see all this code. You can see all the code I'm writing. I'm doing Rust stuff at the moment. Lots of bits and pieces. So yeah, drop me a follow. Definitely always happy for people to swing by. Cool. So we'll say if not f log failed open. I'm trying to not use the word failed in my error messages, right? If it's an error message, something's gone wrong, something's failed. So my error message is just open file name. I think that makes a lot of sense, right? This is something I learned at my old job. They're always like, don't say error in your error message. It's an error message. We already know there's an error. Just tell us what's going on in the message. It makes things a lot more readable. That makes a lot less noise. I'd literally never thought of it before, and so I felt a bit silly when it was pointed out to me, but now I write all my errors like that because it's better. It's better. Cool, fopen. So once we've opened it, we've got our WAD file, we want to read the header. That's going to be the first thing we do. So we're going to say struct w header. We're going to make a header, and we're going to say fread, and we're going to remember the order of things this time. Just kidding, we're not. We're going to do it from here. So fread, we're going to read into the header. We're going to read size of struct WAD header. We're going to read one of those, and we're going to read from the file that we have open. Excellent. Cool. And if this is not equal to the size of a struct WAD header, then something's gone wrong, and we're going to have an error. We're going to log an error, read WAD header that is the... It's always hard to find that that backslash sometimes. Not enough. Open WAD header. Read. Wrong number of bytes. And then we want the name of the file. And we return 0. Cool. Cool. Okay. So now we have this header. We probably, maybe this header, maybe this should actually go in here, and we can just say, instead of the address of this thing, it can be the address of target header, right? We put it in here. And we have to take the address because this isn't a pointer. Excellent. Excellent. This, we dereference, and then we have to take the address again. Cool. Ah, Sunupsider redeemed Tune Break. I forgot I still had this on. Last time I played Tin Whistle on stream, it sounded a bit like shit, but I do actually have a new toy. If you give me like 5 minutes to just finish this thought, I'll get my new toy and I'll show you some really cool music. But that's gonna take a second. But that is cool. I forgot I still had that on. I was gonna tweak it a bit, but I will honor that. I will honor that, Sunupsider. But I just need to finish this thought. So what header? Blah, blah, blah. Open. Open. We have a header. We kind of want to say to do check ID version, and then we want to say target index equals malloc size of struct wad index times target header index entries, and then we want to fread into target index, and that is a pointer, so we don't take the address. We want to read size of struct wad index times target header. Well, actually no, we want to read that. We want to read this many of them, and we read that from the file, but we need to fseek first. We need to fseek this file to target header index offset times, except the block size should be in here. The block size should be in here. And I guess it should maybe be a uint32t, because we want it to be, because this is a file we're reading, we kind of need this to be consistent. So, one target index entries, target header, of fseek to this times target header dot block size. And we seek set, which is the start of the file, I believe. This is now w header dot block size. Beautiful. Okay, so this will just dump the whole index from wherever we've said it's from, which is cool. I'll be back in 1 second. I'm gonna do the tune break, and I'm gonna show you my new toy, because I think, you know, it's been about 40 minutes. Good time for a little break, a little stretch, a little bit of music. And yeah, I'm really excited to show this thing off. We are building towards a music stream. Once I hit 1,000 followers, I'm gonna do an entire stream of music, but for now, I'll be back in 1 second. Which is cool. Okay, so we've got to do a little bit of error checking here. We want to say if not fseek, if it returns 0, something's gone wrong. We want to log an error. Open wad header. Seek. Let's just say seek. Seek to index. File name. And let's put the block offset as well. Index. Where's index offset come from? Index offset is in target header. Cool. Target header index offset. Wonderful. Yeah, Bobby says 26,000 channel points. That's 26 tunes. I'd better keep learning. Better make sure I know a couple of tunes. I might put it up to like 3k or 5k or something. I don't know. I want it to be a more special thing. I don't want people to just do it willy-nilly. But that's fun. That is fun. Hopefully it's not too cringe. I think the tin whistle was a bit cringe. I think a nice 1800s wooden flute, it's a bit less cringe. That's my professional assessment. I'm no cringe master, apart from you know, in the obvious ways. I'm not an expert on cringe, so I would appreciate feedback from people. If fread this is not equal to size of, I'm gonna have to put this on a new line, size of struct wad index times target header index entries. So if we haven't read the correct number of things, that's also an error. We want to say log error read index. Return 0. Otherwise, we've set everything up, I think. We've got an index. Oh, we need to... Should I copy the index size into here? Nah, it's just part of the header. That's fine. So index size, what index entry size? Get index entry. That's going to be part of this. Okay, that's good. That's good. So this is our public API. Now we need a private API. I guess it's not the private API. They're private functions. Cool. Cool. So our first private function is get index entry, which is going to return a pointer. Wad index get index entry. We take a wad file f. Anakim Luke, hello, welcome. How are you going? How's life in South America? What's the weather like down there at the moment? It is alternating days in Melbourne right now. Alternating days, hot and cold. Let's just pass the wad in. That makes more sense. Then this function can work out fields and stuff. It makes a little bit more sense. Makes a little bit more sense, especially if we ever change the structure of this index to make lookups faster, which we may or may not do. There's no guarantees. Cool. So we have this, and then we have a uint32t hash name, or actually it's a name hash, to be more precise. We should probably also have a function, and this needs to be part of the public API, where we say uint32t hash wad hash name, which takes a const char f name and does some stuff with it. I need to look up implementation, some hashing algorithm that's pretty fast. We'll find one. We'll work it out. It's not too tricky to do. You just need if you just pick a prime number or two, you'll be right. Okay, so get index entry. How do we find an index? We do a dumb loop. For int I equals 0, I less than our wad file. This wad file should be called w. Wad header index entries I++. Okay, if the index entry, if wad index I dot what's it called, hash equals name hash, then we've found a match and we return the address of wad index I. Otherwise, if we full out the loop, we return 0. Easy. Most days are bad, some days are terrible. Only a few days of the year you're able to not have a fan next to you 24/7. Wow, that's pretty hot. And Australia's pretty hot, but we're not near the equator. I think I'm, apart from Tasmania, as far away from the equator as you can be in Australia. So it's not hot and sticky. Queensland in summer sounds like an absolute nightmare. Move somewhere colder, south of Brazil or another country. Swedish jobs. Huh, yeah, Sweden. Nice. That'd be cool. There's a lot of South Americans in Australia. One of my friends says, and I tell this story sometimes, one of my friends says whenever he goes to the gym, if he goes at like 5 a.m. or 6 a.m., it's always like bronze buff Colombian dudes playing like Latin music, just pumping. They love it. But yeah, I know quite a few South Americans around here. Cool. Get index entry. So we can get an index entry. How do we hash? What's a good hash algorithm? CRC32. Is that a hash algorithm? Checksum. Not quite what I want. Dumb string hash. How do we do it? What's a good hash function for strings? Cool. Sold. DJB2. Yeah. Now these are longs, but longs might be 32-bit depending on when this was written. February 1990. Yeah, okay, so I think long means 32-bit here. Case 33, Dan Bernstein, complang.c. Yeah, let's do this. Let's do DJB, DBJ2. I can't read. Words are hard. Cool. Unsigned car string. Let's let's treat them as unsigned. That's good. Also, we probably want to just retabulate this. Cool. And let's put a bracket around it, because I like that. Hash, now instead of unsigned long, we're going to have uint32t and c. See, this is weird, right? Because this is an int, but this is an unsigned car. And this is like old school C style, and I don't like it. Unsigned car C. Cool, hash plus C, return hash. Nice, nice. I like this number. I like this setup. This is good. This is good. And let's give credit where it's due to DJB2 from this website. It's good to give credit. Good to give credit. Good algorithm. Does equal in Vim not work well for me? My keyboard is small. So I have a layer to type symbols like equals and brackets, and for some reason my layer keys are not responding very well. I think I need to take my keyboard apart, maybe just like hot swap them out. I do actually have some spares if the keys themselves are dodgy, but I probably just need to give it a clean. There's probably just some like hair and stuff in there. I've never really given this keyboard a proper clean, and I've owned it for 2 years now or something. It's a while. So it's probably due. I live streamed cleaning this keyboard up when I first got it. Yeah, this is a Plank 40% ortholinear keyboard. Have you not seen this before? I did a whole stream of because when I got it, it had these really clicky switches. Hold on. I don't know if I can get them easily. Nah, I don't know where I put them. But these like, I think they're like bronze. I can't remember, some bronze switch. And so I replaced them with, I think these. Yeah, these. Which look very beautiful as a switch, and they're very good. They have a good weight. They're like a little bit heavier than a black, but they're very smooth. They have a slightly longer stem, which I like. Makes them feel very good to type on. So yeah, my customized Plank, they're hot swaps, so it was really easy to do, but I just need to take it apart and give it. I can see there's a lot of hair and stuff in there. You know how keyboards get. Those switches are very unique. They're not very common. You're not gonna get them easily. I don't know if they even still sell them. I didn't really notice there if they were still for sale. But yeah, they're good switches. Highly recommend. Highly recommend for lots of typing. I've done a lot of typing on this board, and it has not failed me. Okay, so read file, get index. This looks good. This looks like real code. Let's put this in a corresponding header. Right, some of this stuff needs to be in a header. WAD file doesn't actually, I mean, because we're dealing with pointers, we never actually need to expose this anywhere. So let's define this. Let's predefine this. So struct WAD file, that's all we need. We don't need to know what's in it, because we only ever use it by pointer, except inside, in our internal APIs, and that's good. Then we need our functions. We need this function. We need open. Actually, wait, we do need to know what's in a WAD file, because we need to make one if we're passing a pointer in here. It'll need to live somewhere. Can we malloc it? Let's see if this works just with the forward declaration. That would be better. And then we want to read a file as well. Except I'd better copy the whole function definition. God, I can hear someone practicing drums. There's some youths that live near me that have a band, and I think that's cool. But like, they practice drums, and I support small musicians. I do a lot of flute playing, but drums are like something else. You got a small keyboard and it's good. What small keyboard do you have? Is it a 40% or is it like a 60 or something? You have left bracket mapped to backspace. What the hell? That's some psychopath stuff. I guess on this, I guess on normal keyboards, you have to like move your hand. I don't have to move my hand to reach backspace anymore, right? Like with my finger on J, I can comfortably press backspace because it's also close, and that's a good thing about ortholinear. But it's kind of weird. Okay, so if and def source wad h define. Always remember your header guards. Things go very wrong when you forget them. Let's see if we can open a WAD file and if it works. I mean, well, I need to build a WAD file. I guess that's the other thing, right? How do you build a WAD? I could write a C program that does this, but that would kind of stink, right? Because doing stuff in C sucks. One's comfortable, the other one gets you away from the home row. Yeah, I'm lucky to have a keyboard where backspace is reachable from the home row. That's the good thing about the 40% ortho size. I really want a second 40% ortho board for gaming with better gaming switches, because these aren't, the long stems I don't think are as good for FPS. I've got my MX Cherry Black gaming keyboard on my desk because I've been playing a bit of Quake lately, but yeah, it's rough. I really like the ortho setup, and so it's hard to go back when I play games to staggered. You use the left palm of your hand to activate the function key. Function 1 to arrows. Just don't use the arrow keys. If you're using Vim, who needs arrow keys? Arrow keys are for scrubs. Just rebind every program to use HJKL, right? Or just don't use programs that need the arrow keys. That's fine. Name hash. That would be a good idea. Okay, let's write a Python script to build a hash. Cool. So, we're gonna have to think about this. And we're gonna do this in Python because it's better. We're gonna have to do this in Python. Oh, well, we don't have to, but we'll do it. So let's say new wad. Should I do this with a class? Maybe I should do this with a class. We'll make a class. We'll have entries. Entries will be a list of files. How do I press Control F? I press Control and I press F. I use Vim, so Control isn't that important. One thing about doing this in C is being able to F read and F write the structs. This is true. Maybe I should just do it in C. Maybe I should. It's also kind of fun, the idea that I could actually build the WAD on the PlayStation 2. Maybe? Alright, you're right. I'm gonna do it on I'm gonna use what I already have. We're gonna make source bin. Like you would do in Rust, and we'll say make wad.c. We'll include wad.h. Card argv. What am I doing? Rust has rotted my brain. Is that right? This looks wrong for some reason. Anyway, it's weird. Palm press control. Yeah, I like using a finger to press a key is the conventional wisdom. Using your palm to press keys is bad because it's like a really unnatural movement of your wrist. Rotating isn't as good either. Again, ortholinear is good because you don't have to rotate your wrist in the same way to press stuff. You just move your fingers up and down, which fingers are good at doing. Doing this all the time, I wouldn't recommend. That's a pretty bad motion. You're gonna fuck your wrist up. Cool. So for every file in our arg count, you can do it with a double pointer. You can do it with a bracket. That's fine. They're the same thing in C. I often see it with a double bracket. I actually see this a lot more than double asterisks. But you know, there's options. There's different options. Okay, so what are we doing? We want to build a WAD. We want so for every file, let's say for equals 0, I equals 1, I less than argc, I plus plus. We have to do this the first time. We're gonna have an int, let's say int file count is argc minus 1, maybe? It's been ages since you've done it. You like the brackets? That's how you do it? Yeah. It's more conventional. I don't know why, but it's more conventional. It's been ages since you've done C, C++. You forget the details around what's acceptable regarding arrays. If you're ever confused about what's acceptable regarding arrays, the rule is there are no rules. You can do anything. You can read anything as an array. C doesn't give a shit. An array, it just turns it into a pointer dereference. WAD makes you think of Doom WAD files. We literally had the Doom WAD file spec up earlier. I closed it now. But yeah, Doom packages a bunch of files together into a WAD. This is the same idea. It's implemented differently. I'm copying what PlayStation 2 games do with a bit more of a view to reading things off of an actual disk with, blocks and sectors and stuff. But same idea. So we have a number of files, which should be the arguments -1, I think. That sounds right. So we're just going to call this, right? We'll use it. We'll say make wad, or maybe pack wad, file1.tga, file2.txt, file3.foo, etc. And we also probably need to have, let's say, index size. I guess we don't need to know that right now. Let's say file wad total file size equals 0. So for every file we add, we increase the wad total file size, and we're gonna have block size is 1024. To do make this an argument. Ideally, we'll be able to say, block size 1024 or whatever, right? Depending on how we want to pack it for the disk. But for now, we're going to hard code it because that's easier. Awesome. So the first pass, we need to work out. Do we need to do this in 2 passes? Kind of, because we need to work out how many files we're going to have, like what the total size is. Then we're going to allocate. Oh no, we don't need. I'm assuming the index comes first. If we put the index at the end, we don't need to do it like this. So let's open a file. Let's do it. And let's open standard out, because that's good. That's a nice way to do things. This is a bit like cat with some extra rules, right? With cat with some alignment rules and an index. It's a bit like a tar file in a sense. Maybe we could just use, existing formats, but let's do it like this. Let's build our own because that's fun. So let's say file f is fopen. We don't even need to fopen it, right? Is std out? Is std out an fd or is it a file? It's a file. Perfect. Okay. Perfect. But we'll still put it in a variable because we might want to not use standard out at some point. We might have a dash out, a dash o. But that's fine, that's fine. Okay, so for each thing, right, here's what we do. We've got to write a header. And I guess maybe we just write a dummy header, right? So let's say, so the first thing we need to do, 1, write a header. 2, write the files, and then 3, write an index. And we're going to do a second loop to write an index, because I think that makes sense. But this is good because then we don't need to buffer anything. We just write everything in one go. So write a header. Okay, so let's say struct wad header. Head is just 0 initialized, and we're going to say fwrite, and I need to check the function order for fwrite because I can literally never remember these. Fwrite, fread, fwrite, pointer, size, nmemb, stream. Awesome. So head size is size of struct wad header. Number of members is 1, and we write it to f. Perfect. Perfect. So we've written a dummy header. And we'll come back and fill in the header. Cool. We could also just kind of seek past there, but let's write. Is standard out opened for binary writing? I don't know. C make std out open for binary writing. Is this something we have to do? want to keep it compatible with Linux. F reopen. What does F reopen do? I assume this will be implemented in PS2. Well, no, so this doesn't need to be in PS2 SDK. This is just what we do, null. And this returns a file. Cool. Okay, this is even better. Reopen standard out, but for binary writing, because if we try and write it not in binary mode, we might have some problems. A, B equals BA, yeah, but they're literally equivalent, right? Because of just, yeah, indexing rules. There are no array rules in C. There are no array rules, except for the ones that do exist. There are no array rules until there are, and when there are, you know, because you have a really sad time, but usually there aren't. Cool, so we write a header, binary mode. For each file, we want to const char fname is argvi. We want to say file pack is fopen fname and read in binary mode. And then we want to, is there an fcopy, or do we have to read, like, can we, let's just, hold on, Linux, copy all of one file to another, right? Can we just do that? Can we just put, like, plug two FDs together? Linux C. Oh gosh. Okay, we have to do it manually maybe. Send file. Okay, we're gonna do it the stupid way. Long f size equals f. We have to fseek to the end, right? We have to fseek pack 0 seek. And what is the end of the file? It's set, it's car, and it's end. Seek end. Easy. Ftell. Yeah, there's a syscall to do a file copy. Yeah, it's not quite what I want. D has ufcs. Fun A is a.fun. Huh. And this is basically what, you know, a lot of like class systems do, right? They just make the thing the default first parameter. It's kind of easy. It's kind of fun. Oops. Sorry, one of my friends left milk at my place. Oh gosh. Sorry, I suddenly had a lot of messages on my phone just then. Universal function call syntax. Yeah, you know, this is what Lua does as well when you use a colon. But then you forget to use a colon, you're like, why is my code not working? Cool, so, size of the file, let's rename this to target, I think that's a better name. We seek to the end, and then we ask the file what it's up to. That tells us the size of the file. And then we are gonna make a buffer, let's say, unsigned car buff. Let's just make it a car, I guess. And let's say malloc size. Then we want to fread, we want to fseek the file back to the start, seek set. This is the way to do this, right? It's stupid, but I think it's the way to do it. Indeed, this works for anything, even freestanding functions. That's kind of neat. It's a weird idea, but it's kind of neat. I think it's one of those things where it's like operator overloading, where it can get really ugly really fast. But there are probably neat ways to use it. I don't think D's ever been concerned with ugly operator overloading, you know, ugly code concerns, right? I think they want to be maximalists and support everything, give people the tools to write really ugly code, but probably people are sensible and won't do anything too bad, right? That's my 1,000-foot view of D. Give everyone all the tools they could ever want, even if it means people can do stupid stuff with them and build foot guns. Just give them the tools and trust them to do the right thing. Okay, so we want to fread into this buffer size. We want to read one thing, and we're reading from a target file. Now we have a buffer with everything. We want to fwrite from buffer size 1 into, well, the other thing we want to do is to align the file to a block. Yeah, D feels like C++ with some more sensible defaults and a few neat features added in. Everything I say still stands because that's my thought on C++ as well, so that's good. Ugly code finds a way. Never underestimate the power of a human being to write ugly nonsense code that everyone will hate maintaining forever. F. Let's rename this to output. I think that's a better name. It's not a much better name, but it's a little better name. Okay, so let's say long current offset is ftell output. So where in this file are we? I don't know how this works with standard out. I assume it starts at 0, but that would be interesting. That I don't know how this works with standard out. I would imagine, especially after calling f reopen, that ftell will give us something sensible, but maybe not. And then let's say long remainder is current offset mod 1024. So what is the remainder when divided by 1024? So, D has a GCC front end. Hold on. I suspect it's not part of the PS2 dev bundle. D GCC front end. What's the binary called? Because I don't know if like there's Fortran and stuff in GCC, right? GDC. Okay, hold on. Let's try this. So MIPS 64 GDB, no GDC. It's not there. These are all the binaries that are built as part of it, right? PS2 SDK only enables it by default, so maybe you could build it. That would be fun. That would be fun to try. Can we write Fortran for the... It's Fortran, isn't it? GCC Fortran? Something like that. Yeah, it is... Yeah, G Fortran. Can we write Fortran for the PlayStation 2? So if we add the remainder... No, if we add 1024 minus the remainder, so can we fseek output, and this should be block size. We should be able to do this, right? Done. Yeah, all the fun languages do LLVM, which sucks at MIPS and doesn't have PS2 support. Someone tried to port Rust to the PS2, and they got some stuff working, but it's hard. And what makes it really annoying is that Rust has their own LLVM fork, which means that you would port Rust, and then no other LLVM language would work. The real big brain thing, and I want to do this stream one day, is getting a WASM runtime on the PlayStation 2 and then running Rust via that. Because you can compile Rust to WASM, right? You can compile everything to WASM. So just do it through WASM. That'd be cool. You can imagine the clickbait thumbnail already, right? Running Rust on the PlayStation 2. It writes itself. It'd be perfect. You could do it in all kinds of weird old systems, right? WASM runs on a lot of things. There are some very minimal WASM runtimes. This is getting concerning. Hold on, I'm gonna write a test program, okay? I need to write a test program because I don't know what I'm doing. Include, you can see I want to write import, but we have to include because it's C. There's no such thing. Int main. So what if let's do exactly what I had before. Let's say file f is f reopen null write binary std out. Okay. So what do I get from this if I say long O is f tel f? Printf and then we need to put a new line here as well. ftel is -1. What if I write some stuff? What if I say f to f? GCC a. Okay, ftel is -1. The file is a thing called a pipe. Data flows through the pipe, -1. You can't do that to a pipe. Okay, we can't ftel a pipe. Maybe it is actually better. Like, I feel like I'm trying to write clever code here, but what I should be doing is just building the entire WAD in memory. Like, just build everything in memory rather than trying to stream it to this file. And that probably makes more sense. So let's do that. Work out how big to allocate. We could also do this in one pass with realloc, I guess, but how does realloc work again? POSIX programs on your memory reallocator. Old object pointer. A pointer, new object has the size specified. New object should be the same as the old, blah blah blah. Any bytes the new object have indeterminate values. Size of the space requested is 0, behavior. Okay. So let's not be stupid. Streaming this in one go would be nice, but let's just write it to a big buffer in memory. That would be better. That would be better. So let's go car in, let's just call it buffer. And yeah, let's make it a pointer. Let's say malloc, because if we make it static, we probably can't realloc it. We're gonna malloc, how big should we say? Let's go for 1024 times, let's say 8 kilobytes. It's too small, but we'll go for it. And let's go size t buffer size is times 20 maybe, and every time we exceed it we'll grow by like something. Better C disables these features. The garbage collector, type info, module info, classes, built-in thread, dynamic arrays, associative arrays, synchronized keywords. Wow, that's kind of cool. I like having a built-in, you know, kind of like the MicroPython equivalent, right? But it's just part of the language. That's nice. That's neat. Okay, so we write a header. Now for each file, I shouldn't have deleted as much as I did, but that's okay. Actually, let's hold on. Let me copy this. And I'm going to undo it and go back to this because I got overzealous with my deleting. We're going to keep this. And then current offset. So this can go output. We need to open the file still. Except now instead of reading it to this buffer, we just read it into the actual buffer. But we offset it by, let's say maybe buffer head, which is going to be 0. And now we don't have to write a header ahead of time. What we actually do is say buffer head plus equals size of struct wad header. That's what we want. Okay, now we're cooking. Now we're cooking. So the other thing is, before we start doing anything in here, this should be called the no fun mode. I like that name. I like that name. No fun allowed. Only low-level C programmers. You know, it's like the low-level C programmer club. No fun. Cool. I might have to head off soonish, so we'll see how much more of this we can do. We'll see if we can get a WOD packed. Otherwise, maybe I can finish it off stream. We get the thing, we get the size, we move it, we read into the buffer wherever our head is. Now, the thing we need to do here is align the buffer head. So let's do it. Let's say while buffer head mod block size is not equal to 0, buffer head plus equals 1. This is the stupid way of doing it. You can do it the math way, or you can do it this way. I like this way, because I know I've done it right. I don't need to test it. I don't need to verify it. This is easy. Cool, so we make sure we're aligned at the start of a blockhead, and that's good. How do we remember this index? This is the only thing. This is the only thing. File, I mean, we know how many entries there are going to be, actually, don't we? Buffer head. And the buffer head kind of tells us how big the file needs to be. Okay, this is better. This is better. Our header, we actually kind of know how big it needs to be, and we can pre-allocate the index because we know how many files there are. Pre-alloc index. This is 2. And now we just put files in buffer. Gosh, everything's blowing around. Okay, we're getting there, we're getting there. The only thing missing here to do, grow if too big. I don't even know if the header needs to be filled in. ID version, index entries, index offset. Yeah, okay. So the only thing, so we can actually completely do this. We can completely do this. Let's say struct wad header head. It's going to be a pointer is buffer. The first thing in our buffer is the head. Head version is 1. Head ID is 32-bit. So let's maybe call it AABB. Right? Just a nice simple version. Head index entries is file count. The number of files we're putting in here. Easy. Index offset. It's going to be 1. It's going to be in the first block. And the block size. Cool. Beautiful, beautiful. We move the head up by this. Now we're gonna allocate space for an index. So index, let's say struct wad index. And let's actually just move it up by block size. Header smaller than block size. The header's less than a kilobyte. We're pretty sure. We're pretty sure. Okay, so now we're going to pre-allocate an index. Buffer plus buffer head. Right, this is where the index starts. The current head of the buffer. That's beautiful. Now. The size of the index is size of struct wad index times head, well, times file count. Let's do head index entries, because these things may not stay in sync. We might put like extra data in there at some point, maybe. Let's go with, you know, once we've written the header is the source of truth. The header is where this data really lives and what owns this data. Cool. So, if, let's say, while index size buffer head plus equals index size. Beautiful. So we move it up by this much. We move it up by this much. And it might span multiple blocks, and that's okay. We move it up by that much. We'll, you know, we'll work it out. We'll work it out. So we've pre-allocated that index, and this is good. We move our block to the start. Okay, so if buffer head plus size is greater than buffer size, then we want to realloc buffer, and let's go buffer size times 2. Let's double it. That can't go wrong, right? There's no way that can go wrong. Easy. I'm sure that's fine. I'm sure that's fine. Then we read into it. Now this returns a void, return value, realloc pointer to the possibly moved allocated space. So we want to say buffer equals. And if not buffer, print fprintf to std_air we return -1. Cool. If we can't reallocate, then that's an error with a new line. Otherwise, we read into the buffer at the current buffer head for the size, then we say buffer head plus equals size, and then we need to write into the index, and we do that by saying index I -1 dot. Now what goes in an index? Wad. And this is why all this stuff should actually just be in the header. Let's not be precious about it, right? It doesn't make sense to be precious about our WAD definitions. Everything can understand what's in a WAD. That's good. We don't want to be too crazy with it. Okay, so WAD index, get index entry, blah, blah, blah. That's all fine. That's all beautiful still. Index wad.h index hash. Now we need to calculate a hash equals wad hash name. I can't type. And this is just fname. Beautiful. So there's a hash, there's a block, offset equals, we do that before here. We say buffer head divided by block size. The size is equal to size, and let's say the extension is equal to 0. Beautiful. Now we move the head up and we align the next thing to a block. Nice, nice. Okay, love it, love it. This is good. This is good news. With a realloc and everything. And so once we've done that, we're ready to write the file. And we only write buffer head bytes. So we say, and let's do a reopen. Let's say file out is freopen null. We're writing in binary mode and we're writing to standard out. Fwrite buffer head 1 out. Beautiful. So this needs to be /wad. Let's go gcc source bin make wad.c. That makes sense because we need std lib.h, and let's do this from here. Do we have, okay, so I need to go gcc source bin make wad.c wad.h. Struct wad file, line 21. Yep, didn't have a semicolon there, that makes sense. Buffer. Warning, error, initialization from incompatible pointer type. That's nice. I guess it doesn't like me doing that. Struct wad header. When did this become an error? I thought C was really chill about this. We can put brackets around that as well. Wad hash name. Oh yeah, right, because we need source wad.c as well. Cool. Undefined type struct wad index. Wait, is that because wad.c doesn't include wad.h? It is. That's very funny. Include wad.h. I should put this in the make file, but that's okay. Stir++, yep, because this isn't called stir, it's called fname. Okay, we're closing in, include std lib.h. Nice, okay, we're almost there. Log error, oh yeah, so we've got our log headers. I guess we can include log, let's just define log error s ... as f printf std error s. I think that's how I do it. Target header incompatible fseek. Hold on, why am I fseeking? I'm seeking to hear. There's no member named W. WAD file 70. This must have been when I was thinking about playing the flute. Index block offset times W header. Okay. Oh yeah, and I should name it. I'm gonna name it packwad. Cool, and that does nothing. A.out. Okay. Cool. Test.wad. That looks like it's about the right size, so that's kind of cool. I probably also need like a read wad test, right? So I can read a file out, and I should probably write that as well. Let's go source bin read wad.c. And let's just do this test. And this is kind of nice to test not on the PlayStation 2, because stuff is always harder to test on the PlayStation 2. Much, much harder. Oh no. My plans for tonight just cancelled. That's kind of sad. Cool. So let's go const car wad file is argv1, and we're just gonna read out of bounds here. And we need to check, don't we, if argc is not equal to three args, the name of the binary, the name of the wad, and the name of the thing we're gonna read. Just print out usage. We'll use the name of the binary, wad file. argv0. Cool. Okay. argv1, argv2, and we'll call this inner file. Do I ever use the quick fix list? Yes, I do, but when I run GCC through the exclamation mark, it seems to not work for some reason. When I run GCC through make, I get a quick fix list. I've been using it extensively in Rust. I don't have like syntax highlighting. Oh, I don't have like error underlining in Rust. I just rely on the quick fix list, and people get very upset with me, which is very funny. Okay, wad.h. We're gonna go wad open. If not wad open, wad file, wad. But yeah, quick fix list in Vim is like a superpower. It's worth learning to use. If you don't know what it is and you're listening to this VOD, go Google it. It will change your life. Quick fix list will change your life. You're not keen on the linter screaming at you every keystroke. Yeah, it's annoying. It breaks my flow, right? I want time to think about what I'm doing. I want to reflect on my changes. Open a WAD file. Cool. We want to fprintf standard error error open WAD. I know I said that I didn't put the word error in my errors anymore, but this has no other context. This will be the only output of this program if we're not careful, so it's kind of worth thinking about that. WAD file. Cool. Okay, so if we can't open the WAD, that's good, and then we want to read a file. Let's make it a car buffer. Let's make it a void buffer. Data is malloc. Let's make it 1 megabyte. A whole megabyte of data. Crazy. Absolutely insane. I should probably, hold on, I missed something. Make wad, not .py, make wad.c. I should probably free the buffer at the end. And I should also probably, do you close standard out when you're done with it? I guess you don't. I guess that's part of the operating system. Anyway, this is a dud file. Okay, cool. It's always nice when you remember to free your code. So we've got data. We want to say if not wad read file. We've got our wad, which we have to pass in as a pointer. We have a file name hash, which is going to be wad hash name in a file. We're going to have the target buffer, which is data, and we're going to have the size, which is 1024 times 1024. I guess we don't really know how much we've read. That's probably what we should return, right? Size t. We get the size of the file. Probably want to, yeah, just say how big the thing we read was. Return index size as a size t, which is going to be beautiful. Cool, readwad.c. Cool, so we've got the size, and then we want to, again, probably do what we did before and say file out is f reopen null write in binary mode, and we're reopening standard out for this mode. Then we're going to say f write data size 1 out. Beautiful. So this is going to dump the file back out exactly as we put it in. Then we can do a diff and see if our WAD behaves itself. We're going to need to include all the things from make WAD. And this is the test. This is, was it all worth it? Was it all worthwhile? Cool. So we're going to do the same thing we did for this. And the file is tiles test.o.tga. Oh no, we got an error. We returned 255. Nothing got printed out, but we returned 255. That's a bit weird. ls alh foo is empty. Well, we should probably say if not sz, or if sz equals 0, then that's an error as well. In a file return -1, otherwise we want to return 0. And it just dies. Huh. Oh, hold on. I need to put a new line. That makes sense. If you don't put a new line, it's not happy. It's not happy. And also, that probably means that in wad.c, because I just defined this in a stupid way, this string, it probably has to have a new line after it as well. There we go. Read wrong number of bytes from the header. Oh, that's not good. At least 255 is a nice number. Yeah, -1, my favorite number. -1, aka 255. My phone's been doing this weird thing lately where when people call me on WhatsApp, I don't get a call, which is strange. It's very unusual behavior. At least I know where 255 came from. And at least I was pretty sure that was me and not just random garbage falling through. Oh, new lines are also good as well. Okay, read wrong number of bytes. In wad.c, read wrong number of bytes. Size of wad header. So why could we not read a wad header from this? Well, first off, not wad open. We do check this, don't we? Yeah, we do. So the file opens, that's good. xxd test.wad. Looks like we have real data at the start, and then a lot of padding because we're aligning to some arbitrary boundary. And then we start about here, which kind of looks right, maybe. Maybe? And this looks like pixel data, right? So where's our index? I don't know. I'm a bit confused. How come 255 is -1? Because it's a byte. The error codes are one byte in size. So if you convert a signed byte -1 to an unsigned byte, you get 255. It's the same bit representation. Cool, so this is our whole TGA, and that's good. We know our whole TGA is here because we can see the footer at the end of it. Also, don't targets have a... Maybe they don't. Maybe the header stuff's all at the end. Because it's not 2. Thank you, Cricket. Very insightful, very wise. Okay, so what's going on here? What's going on here? Read wrong number of bytes. Read a header. Structural word header. Okay, I need to remember how many bytes I read. I need to actually remember this. Wow, I accidentally just RB equals... There we go. I hate when you lose your buffer. RB. Oops. D. It's actually an LD RB. I'm trying to be more precise with my C types these days. Okay, so read wad. We only read 1 byte. Why would we only read 1 byte? Why would I return -1 instead of 1? Because it's convention. Different tools have different conventions for what they return, but -1 is just kind of what a lot of people do for a generic error, I guess. Usually 1, 2, 3 are more like precise. It's like it's a specific error, and -1 is just like, I don't know, I gave up. I think I've seen a lot of command line tools behave like that, but yeah, it's very subjective. There's no real reason. Plenty of tools return 1, plenty of tools return -1. It's very subjective. So, size of 1. What if I swap these arguments? Is that going to help? No, we still... Oh, hold on. Open word header. Seek to index block 1. Okay, well that helped for some reason. Return. Return. Yeah, return I don't know. Return I don't care. You can also exit. That's the other thing. If you exit in, that has the same effect. Okay, so seek. Why do we blow up seeking? Index offset times block size. Let's do the multiplication as well. Just so that we log everything. Let's log exactly this. YT comma. Actually, hold on. Can I need to remember Shift P when I'm pasting. I always get that wrong in Vim. 1024. We can't seek to 1024 for some reason. Why does that blow up? I don't know. Let me double check that I'm doing the return value correctly. Fseek. What does fseek return? Let's double check. Upon successful, they return 0. Okay, so I did that literally backwards. Literally backwards. Everywhere I have an fseek that I'm checking it, it's probably backwards. That's good to know. Read index. Error. Read index. What's going on here? Fread. Okay, so I'm going to swap this around. Target, header, index, entries. Why did this work before? I have no idea. But let's try it again. Oops. File not found. That's good. That's good as well. I like that. I like that. So. So. How do we, how do we verify this? Maybe I just want to like, just for testing purposes, right? Hash name, fname hash. Let's just put this in here. And let's packwad. Cool, so we'll redo our packwad. We'll say packwad test, source test, fill, source test, tiles, test 0, test.wad. We'll put 2 files in there this time. Invalid next size. Ooh. Let's not do that. Something broke in there. We can do 1 size, and that's good. Huh? What? Did I? That's good. That's really good. What the fuck? That was unexpected. Am I... argv, What have I done to argv? What? Is that like... I'm reading into env. But I'm reading into env of the surely you should kill my process before I'm allowed to do this. This is why we have security bugs. What the hell? Okay, so the first thing we're going to do now is fprintf to stdr packing file name. How does that happen? What? Maybe I should like not show this on stream in case it doxes me with something sensitive. Okay, hold on. Fname. What did I do? So I can log it out okay, but when I try and hash the name, it's like a different pointer? What? What the fuck? That's so baffling. How does this happen? Fname, S, file name, fname. It's the same pointer. Yeah, directly after. So, but this fname. Where do we use fname? We literally don't use it. Oh wait, hold on. I see what happened. We're literally incrementing the file name. So we're just gonna do that. Okay, so the code is fine. The code is fine. That's good. That makes a lot more sense. Usually this stuff does, right? Readwad. So when we hash this, because it has source as its prefix. Well, that's good. 69 negative 6913. Okay, that's good. That was a good bug. That was a high quality bug. That's very C. Very classic C. Cool. Sorry, just have to keep half an eye on the time. We'll find someone to raid in a sec. Hopefully I can get this working a little bit better and at least read a file back out. File not found. File not found. If not index. Let's log error here as well. Test index. Name hash versus w index I dot hash. This will tell us a lot as well. And actually, maybe I'll go like x. We'll print it as hex. Maybe that's better. Everywhere we show a hash, we'll just like hex it up. Oh, so I really should, hold on. Not source makefile. I'm just gonna go makefile. Maybe. Oh no, I'll do it here. I'll do it here. So let's say packwad, and that was gcc-o packwad. It's, how do I type name source files? So it'll be source. It'll be bin. No, yeah, it'll be relative to this, because when you make -c, I think it actually changes the pathway. So it'll be bin make wad.c and wad.c. And when we do this, it'll be and we'll depend on these, bin read wad.c and wad.c. Tools, packwad, read wad. Cool. Packwad source tiles test 0.tga. Okay, there we go. So now I've got names in hex, which is a little bit nicer. Readwad test.wad source tiles test o.tga. Cool, cool. It's just a bit nicer. I don't have to remember my GCC command. I can just make now. And I should actually get quick fix list errors if I do that from Vim, which is cool too. File not found. Test vs0. Aha, the index does not have a name in it. So that's good. That's good to test. The index hash, the one entry in the index, does in fact not have a thing in it. So let's look at makewad again. Let's look at makewad. Packing file name. Failed to grab buffer. Hash. Index I-1 hash. I-1. So, because I starts at 1. Oh, there goes the light. Bye, light. It only lasts an hour and 55 minutes. No longer. I need to get an extension cable so I can plug it into a PowerPoint. Then I'll have unlimited light. It's a good light. Nice little key light. Very powerful. Very, very dense. So, why aren't we writing this into the index? Maybe I should just read the index. So maybe I should do this, right? Let's do this. Let's make this file do both. Let's make this binary read a file if we give it 2 args, otherwise read an index and just print that out if we don't. Const char wad file. Let's do this, let's do this. So this will be the same. And then we'll say for int I equals 0. Actually, we need to read the index somewhere, don't we? So let's go void data is malloc. I don't know, we have the index set up. We read the index as part of this setup. So let's say for int I equals 0, I less than wad dot header dot index entries I plus plus. Index entries, that's good. For each index, oh, I've got another thought about this actually. I've got another thought. We'll see what we get. We want to say struct wad index. We'll make it a pointer is wad index I. Actually no, let's copy it. That copy makes more sense. Cool. And then we want to printf and we'll just print all the things. So let's say hash equals this, block equals this, size equals this, and extension equals this. So this is idx.hash, idx.block, offset, idx.size, and idx.ext. And it needs a new line as well, because everything needs a new line. Return 0. Beautiful. Okay, this is good. So now in main we just say if argc equals 3, else if argc equals 2, else. Remember to make the hash format spec x. Oh yeah. Thank you, that's a good point. I'm printing them out as hex because it looks better. It looks nicer than trying to read like native 61,000. Less things to read and compare is good. Okay, so otherwise this is our error. We want to say return read file wad file inner file. Otherwise we return read index. Otherwise we do this, and this is optional now. This can all go in the bin. Beautiful. Okay, we now have wad index. That's because this is not a pointer. Cool. Okay, so read wad test.wad. Excellent. Perfect. This is really good. This might look stupid, but this is really good. This tells us that while we have correctly created one entry in our WAD file, we have not actually set it to anything. We have not actually set anything at all there. Completely empty, completely void. So, So. Why doesn't this write anything? I have a suspicion. I have a suspicion about the line of code. I suspect it's this. But that should just put it at 0, right? Why don't we put anything here? Because we read it, we put it into the file, okay. So why don't we update the index? Let's do a fprintf stdr, and let's say, let's make this a pointer, and we'll say address of index I-1. Actually, that's not as useful, is it? I want to say, no, it kind of is. Let's index of this subtract buffer, right? So where are we in the index? Where is this in the buffer overall? And let's dump this as a hex. Binary, struct what index, pointer. Oh yeah, we can't do this math with things of different sizes, so let's make this a carb pointer. This is fine. C knows how to do this. Rules of C. Remember the rules of C. There's no rules. There's no rules. And now we can say make C source tools, and we get this from within make wad pack wad source test fill. No, let's keep it consistent. Let's go tiles test o, and we put it in test.wad. Okay. Is there a way to have a make file? This number is wrong. This is a really garbage number. Is there a way to have a make file? Is there a way to have a make file where if I go make tools, it just calls the make file in source, so I don't have to type -c? Can I have a make file in this folder that just automatically does -c? That would be good. Now let's use my favorite program, because this looks like a memory error. And let's go source bin source packwad source tiles test o.tga. What's this doing? Oh my gosh. Okay. Excellent. Excellent. Heap usage, leak summary, no. Golly. Here we go. Here we go. Points to uninitialized byte. So all these problems, right? These are things. Invalid write of size 4. Yes. Yes. Invalid write of size 4. Okay, so we're writing to garbage. Oh yeah, the link to my website and my panels is broken. I knew this actually. Thank you. I do need to fix that. I do need to fix that. So this is good, right? We've done some pointer math, and we've shown that we're writing to an address in our buffer that shouldn't make any sense. And we can see that when we write to it, we do these 4 writes of size 4, and they're all fucking garbage. So size 4, size 4, size 4, size 4, these bytes. So this does not make sense. Does not make any sense. I-1, which is weird, because I would think that index buffer plus buffer head, I would have thought this was okay, right? I would have thought we could do this. What if I look at just this, right? What if I do this without valgrind? Index adder. So it doesn't like the way I make this index. Buffer plus buffer head. Buffer head is 1024. Huh. Because I would think that if I subtracted buffer away, and from this as a car pointer, I would just get, you know, the block size. Huh. Okay. Something evil is going on here. Something bad has happened when I do this. So buffer size. Why is this wrong? This doesn't feel wrong. We're just doing some pointer math. It's not a big deal. This feels like the safest C I've ever done, right? We can add these things together. We can convert them to a different type of pointer. I don't know what this yes was in relation to, but I'm sure you're agreeing with something good. This is gross. What did I do? What did I do to deserve this? You should be able to do pointer arithmetic like this. That should work. That should be fine. We should get this back as a thing. This is where I want to put this stuff in the buffer. Why won't the buffer let me do it? I'm a bit lost. Okay, I think I'm probably gonna have to call it there. I will fix this off stream, and then we'll have file IO, and then I'll actually do it on a PlayStation 2. Oh, yes to the makefile stuff. There's a way to do it. I don't know how to do it. I know it's possible probably in theory, but I don't know how to do it. That's my problem. But yeah, that would be cool. That would be cool. Anyway, we're gonna find someone fun to raid. So thank you everyone for hanging out. It's been a pretty productive stream. We got some stuff done. Not as much as I wanted, of course. Hopefully next time we'll take this to the PlayStation 2 and actually do some verification. But unfortunately, this is just a bit of a pain. If anyone seems to have a tools target that calls make another makefile, can I do it without having to duplicate every target in the other makefile? I want it to be automatic. If anyone has any recommendations for someone cool to raid, I would love to hear it, because you know, I love sharing the love. I love pushing it on. There's the guy who's doing the kick flipping cars, and that's pretty cool. That we've had a lot of fun with that guy before. But yeah, you know, who's a good stream, who's a good programming streamer we can throw the love onto. Let's do that. Let's do the kick flipping cars. I like that guy. He's fun. I think that guy's a lot of fun. Let's share the love with him. Awesome. All right, well, thank you so much. Thank you to everyone who's been watching on YouTube. I love you all a lot. And thank you for tolerating my little flute break. That was fun. That's a fun little redeem. I'm going to raise the price, though, but it was a fun idea. Awesome. See you guys next time. Bye.